All right. Okay, let's try this. Okay, class. Sure. Okay, good. All right, this is going to be the Algebra 3, and it is 1.2 today. Bluebird. It's a bluebird. Okay. All right, so Algebra 3, you guys got the papers in front of you. And for those two new people, do you guys have notebooks for this class? Okay, you have one just for this class. Only this class. Okay, good. All right, so we're going to be on page 3 and 4 on these right here. So please hand you guys the table of contents and all that other stuff here in a little bit. So if you could, let's start off here. Okay, so, okay. Can you afford 25 cents? 1/4. Okay? So either pay me today or tomorrow, because I have some here. You mind pink? Okay, you're going to put a cover on it anyway. No, it's all right. Don't worry. You're going to put a cover on it anyway, so it doesn't matter. Okay, so make sure you're on page, when we number it, the very first one is going to be, this one's 1. Okay? So, the first one. So, 1, this is going to be your table. 2, 3, and then 4. Okay? So, I'll get you guys the table of contents and everything here in a little bit. All right. Let's see. So we have this. You guys updated your table of contents. Now, this one right here is going to be page 5. This one is page 4. So page 4 and page 5. So let's go ahead, head over to the notebook. Now, don't tape them in yet. You'll see why. No, yeah, it's stapled, but I'm going to show you. All right, so page 4 and 5. So 5 should be your right page, the page on the right-hand side, right here. All right, so you guys recognize those questions that we have right there? Yes. All right, what do we have for the first one? 3n, right? What was the second one? 3rd one? 1/2 n, right? Or n divided by 2, right? And the last one was 3/4 n. Very good. All right. So for this problem right here, okay, we're going to start this out and we're going to go with what we have on this. I tried this one a little bit different earlier, and I had them actually do some cutting of paper, and it actually took too much time, but it was good. They had fun tearing paper up. But anyway, let's see if we could actually figure it out. So the original piece of paper has a length of 8 and a width of 10. So let's take a look. So I'm going to sketch this right here. This is my paper. It is a horrible drawing. So it's 8 inches by 10 inches. Yes. Okay. Now, we're going to go through and fill in some of this stuff. So, takes paper, cuts it in half, then stacks the pieces, takes stacks of the 2 pieces, then cuts those in half again, form 4 pieces. Stacking them keeps doing the same thing over and over again. All right? Let's see. So, it's going to ask you a couple things. So, this is my paper. This little piece right here. It is an 8 by 10. How many pieces is there? Say 1. 1 piece of paper, right? 1. Now, what is the area of that piece of paper? 80, right? So to find the area, it would be the length times width. So it's going to be 80. So 80 inches squared, right? Good job. Make sure you write the inches squared to notate that it's the area. Okay. So now, I'm going to take this and I'm going to make one cut. I'm going to make one cut. So Actually, I got a pencil for this. I took it out, and I think someone took it. Got another one. All right. So I'm going to cut it right here. Right there. So this is a very, very even, straight cut. It is exactly in the center. Even though it doesn't look like it, it's illusion, trick of the mind. It actually is, though. All right. So there's one cut. So how many pieces do I have now? 2. Very good. All right. So what is going to be the area of each one of those pieces? Where'd you get 40 from? It's half, right? So I took my 80, which is the total, and divide by 2. Okay, so each one is going to be 40 inches squared, right? Yeah, that guy.
So, you said it's 40?
Yes. So down here is 40, and up there is 40. Does that make more sense?
I thought you cut the side lengths in half, so it would be 5 and 4.
Oh. No, just one cut. That's all it is. Just number of cuts is one cut. So it's kind of like if you're playing Fruit Ninja and it's just right there, okay? Yeah. All right, that was my jam back in the day. All right, let's see. 2 cuts. Let's take a look. I'm going to take my super sharp knife and I'm slicing right there. So there's 2 cuts there. How many pieces do I have now? 4. All right, you guys ready for the tricky part? Now, what is going to be the area of each piece? 20? 10? 10 or 20? I hear 10, I hear 20. Show of hands. Who said 10? Other hands. Who said 20? All right, I got to go with the 20. Okay? Because watch this. It is 20. So one piece is 80. 2 times 40 is 80. 4 times 20 is 80. So I'm still adding them all up. It's still the same pile of papers. Still the same surface area, so it's always going to add up to what? 80. There we go. It's always going to add up to 80, and that's what I'm getting at. All right, now, this is going to be tricky ones. So this is what I did here, so you guys can see this now. So I have, I don't have it as 4 yet. Hold on. So we're going to take this, and now we have to divide each one. So you have to think about it carefully. I'm stacking this. So, okay, there we go. Okay, there's my 4 pieces. Okay, there's my 4 pieces that I have right there. Yes? Okay, so now I'm going to stack them. Stack, stack, stack. Okay, so I stack them, and now I have to cut them again. Right? Right in half. So I'm going to go like this. How many pieces am I going to have there? 8. Because I took those ones right there. There we go. So I should have 8 now, right? So let me see. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Good job. So it's going to be 8 pieces, right? Now, what is the area of each piece going to be now? 10. Very good. 10 inches square. Yeah. And now, again, if I do the total area, what's the total area have to come out to be? 80. Very good. So now let's do it again. So now 4 cuts. Now, I think you guys understand the concept now. So if I do 4 cuts, how many pieces am I going to have? I will have 16, right? There will be 16. And my area for each should be 5 inches square. All right, very good. Now let's take a look at number 5. So on 5 cuts, How many pieces should I have at 5 cuts? 32, right in 32. And the area of each should be? 2.5, very good. So 2.5 inches square. Yes? No? Maybe?
Yes.
Anyone have any questions? Okay, so we're going to have to figure out some terms to go along with this now. So describe in words. Describe in words. So you actually have to use like real words, not real sentences, but still. Describe in words how you can use results after 5 to find the results after 6. In words. So think about it. In words. We're going to have to write this out in words. So I want you to get some time to ponder on this real quick.
You want to write it down now?
Yeah. So. In words. All right, anyone want to share their words with us? This guy.
You will find the pattern in the table and use the same formula to get 6 cuts.
I agree, but I want to know what the pattern is. So what would I do?
Oh, you would double the number of pieces.
Double the number of pieces, right?
Yeah.
So 2 times the number of pieces, right? Now spell pieces for me. Is that right? Because that looks wrong. Yeah. I'm dyslexic, so every word looks wrong to me. So, anyway, so that gives you a number of pieces, right? And what about areas? So it's going to be the area, right? So it's the area divided by 2. Super easy, right? All right, let's take a look. Says 3. Says, on the given axes, sketch a graph of the number of pieces as a function of the number of cuts. How can you see on the graph how the number of pieces are changing with each cut? Okay. At 0, how many pieces were there? 1. So try to put 1 in there, so that goes right there. At 1 cut, how many pieces? So 2 right there. At 2 cuts, you guys have it on the other table, right? 4. Very good. 3. 8. Very good. So 3 is 8, which is right about here. 4. 16. So 16 should be right about there. 5. What is it? 32. 5 was 32, right? And 6 was, it's off my graph, isn't it? It's way up here. Way up there. So look at this right here. All right, can you tell me how that is growing? There's a special word for it. I don't know if you've ever heard of it before. exponentially. It's going up exponentially. If you notice, as it goes up, it keeps going up faster, right? So the more we go this way, the faster it goes. So it just keeps going like that. All right, now let's do the same thing for number of cuts and the area. So at 0 cuts, what was my area? Okay, so I'm going to put a dot right there. 1 cut. 40. 2 cuts. 3 cuts. 4 cuts. 5, right? 5 cuts. 2.5 and 6 cuts. 1.25, which is right here, right? All right, if you notice,
That's exponential too, right?
Kinda. All right. Now, this one right here is going to leave me with an interesting concept. So on the previous page, didn't I keep saying it's going to be all added up to how much? 80, right? 2 times 40, 80. 8 times 80, right? It's just each one keeps getting smaller and smaller, right? Okay, here's a strange concept. On this graph right here, will it go to 0?
No. Well, yeah.
No, yeah. I see some head shaking, a couple of head going around. All right, I need a volunteer. Volunteer. Come on up here. Come on. All right, so I need you all the way up here. So this is what you're going to do. Okay, so we are going to have you walk across the classroom. So start right here, right at Miles Morales. Okay, all right. So she's going to walk from here all the way to the other side of the classroom, but she's only going to go half the distance. Okay, so first, go half the distance. Okay, so that's one, right? Now, go half the distance again. No. Go back to the half. Go back to the half. Now, it's half of a half. Yeah, half of that distance, right? Now, again, go half of that distance. I know, that was too big of a step. Come on now, come on. I'm terrible at this. All right, half the distance again. Half of the distance. So, okay, now look how far is it from your shoes to the wall, right? Okay, where is halfway in between there? Put it there. Okay, there you go. Now look down again. Where is halfway between you and the wall? Okay, go there. Now, you guys understanding? Will she ever make it there?
Yes.
No, because she's only going half the distance all the time. It's just like the total distance, what we're talking about, is total area. Thank you. All right, we good. The total area always has to add up to what? 80. The total had to add up to 80, right? The total had to add up to 80. So in my graph, is it possible to multiply by 0 and still get 80? No. Anything times 0 is? 0. Thank you. That's what I needed. So it's never going to go there because these together have to add up to 80. So that was the point. So on this graph right here, it would be like an asymptote. It's going to come close, but it's never going to touch. Okay? So now, let's see. Right here. Same piece of paper, 8 by 10. How many pieces of paper will Claire have if she cuts the paper in half n times? No, we're doing cuts now, this one. Area is this one over here. And this one's a tricky one. So I'm hoping you guys are pondering, not staring off blankly up at my classroom walls. Okay, so now, anyone think they could have a rule for that one? 1/2 n? Okay, let's see. So 1/2 n. Let's see if that matches. Okay, so let's see. So 0 cuts, it would be, anything times 0 is? 0. So that doesn't work out, does it? What about, you said 2n?
Yeah.
Okay, so now at 0 cuts, what's 0 times 2? It's got to be 1, doesn't it? This right here is 1. This is the one that's gonna get you here. So we know it's growing up exponentially, right? So yes. Yes, right? And it's doubling every time, isn't it? So if it's going to double every time, it's going up exponentially. Okay, so now, here's some background math. Anything to the 0 power is 1. Anything to the 0 power is 1. This is a rule. It really is. Listen, I'm going to make you guys think creatively, okay? This is not going to be hard. It's just creative. It's kind of like if I asked you to go paint a portrait. You're going to say that's hard now, right? Yeah. But after I teach you how to do it, you'll be like, I got this, right? Okay, that's kind of like what we do. We're trying to be creative with our numbers, okay? Just like yesterday's. Remember yesterday's, patterns, right? Okay, that was a good one. I like that one yesterday. All right, so that's going to be 2 to the n. All right, so now let's talk about this one over here. On number 2, why is the product of number of pieces, the area of each piece always the same? Explain how you know. Oh, wait, hold on. I didn't finish this one. So pieces right here. How many pieces will she have? She cuts paper in n times. What would the area be of each one? Okay, so now what will we do with the area for each one now? What's my starting value? 80, right? So I would start with 80, don't I? Is it getting bigger or smaller? Smaller. So what should I devote? What should I do? Divide. Say divide. Divide. So I'm going to divide. Okay. So it's going down by how much? Half, right? It's going half. So watch this. By half to the n. Because right here at 0, I still have 80, right? Because 2 to the 0 power is 1. 80 divided by 1 is going to be 80. Very good. Now do it again. So it's going to be at 1 cut. So when n is 1, that's going to be 2. So 2 to the first power is, say 1, right? So 80 divided by 2, 40. There we go, right? Okay. What about if it was 2? What's 2 to the second power? 4, right? What's 80 divided by 4? 20. You guys see the pattern? And if I did 3 here, what is 2 to the third power? 2 times 2 times 2. Let's try this again. What's 2 times 2? 4. What? Okay, yeah, okay, so, yeah, okay, all right, okay. Let's try this again. Class. Let's try this again. Class.
Yes.
What is 2 times 2?
4.
Times 2?
8.
8. Right? So, it would be 80 divided by 8, which is 10. Okay, let's try this again. You guys ready? All right, we're going to do the 4 now. Okay, so 2 to the 4th power. Okay, 2 to the 4th power. You guys ready for this? 2 times 2 is?
4.
Times 2 is?
8.
Times 2 is?
16.
16. 80 divided by 16 is? 5. That's what we get right here, 5. Woo, you guys just got math today. All right, very good. Y is the product of the number of pieces, and the area of each piece will always be the same. Okay? That goes back to what I had on the table. Why is the area always going to be the same? Same piece of paper?
Yeah, same piece of paper. Just split it up.
Okay, so I got a whole bunch of slices right here. This is my paper, isn't it?
Yeah.
Even though they're tiny, their area will still always add up to 80. So that's why. All the areas will always add up to 80. Oh, flipped it over too far. Add up to 80. And let's take a look at these ones down here. Complete each geometric sequence. Complete each geometric sequence. Okay, so 1 says complete it, and 2 says, okay, find out what it's going to be. For A, what are we going to have?
Times 2n. 2n.
So yes, it is 2n, right?
Yes.
But what are my numbers?
12 and 48.
12 and 48. Very good. Are you guys following? Did I lose anyone here? Because I got one guy right there that's trying to take a nap. He might get hit with the blueberry here in a minute. It's not you. Why do you always think it's about you? What? This guy over here wanted to slap you. I was like, man, don't do that. Okay? Listen. Hey, listen. You were drooling. You were making like all kinds of noises. So, I got it recording right now. Yeah. Okay. So please follow along, okay? All right. B. What is my factor for B?
3n.
3n, right? So my missing numbers are 1080,
Yeah, and 30, 240.
30,
240.
240.
Yeah.
Okay, so now, what is C?
Divided by 10.
N divided by 10.
Yeah.
So this one's going to be
0.2.
0.2. Very good. And point.
0.002.
Excellent. D is a good one. Fractions are your friends, not food. What is it? 3n.
Oh, yeah.
Okay. So my missing one here is 3 over 7. And then 3 times 3 is 9, right? 9 times 3 is 27. And then 27 times 3 is? Try again. 81 over 7. So 27 times 3 is 81. Okay, and what's that last one?
1/3 n.
What is it?
Wait.
N over
N.
2.
Yeah.
So my values are 3 and 3 over 2. Very good.
Wait, no, what time?
All right, let's take a look at what we got. So this should be on what page in my notebook? 5. There we go. This should be on page 5 in my notebook. Right here, I got this on page 5. So now this other thing over here, see this? This is going to be your page 4. Here's your page 4. These is your homework, your practice, your do it, your assignment, whatever it is called. Okay? This is what you will do. Don't you know me? Listen, girl, don't you dare know me. Don't you know no good? No good. Anyway. All right. You guys are going to work on that. Use this time. We have about 10 minutes left of class. You will finish as much as you can. If not, over the weekend. And good news, we should have our first test next week sometime. Heck yeah. Can you feel